is Aino. I am Danish. And I sort of presented myself with three things here: putting speakers on stage, because as Jimmy said, or Jimmy said, I invite speakers for technical conferences around the world. I also help developers talk with each other. I facilitate meetings, especially retrospectives, and then I mess with the heads of students. So I've been teaching for 20 years now. I started teaching at university, then I went into industry, taught in industry, went back to university, taught university, went back to industry, taught in industry, went back to university, taught. This is going to stop soon. Went back to university, taught in university, and then decided to just become independent, and now I'm teaching at the university how to teach, and I am also in industry helping people talk to each other. So that's the short story about me. And when I got invited to this conference, I said to Jimmy, you know, I'm not really working with programming languages anymore. So it's 20 years ago since I did that, so possibly I'm not the right one to talk at this conference. But he said, but what else are you talking about right now? And I said, I talk about how people learn, how the brain learns, because I've been teaching for so long, and now I'm teaching teachers how to teach computer science, so I've done some research in it. And he said, well, maybe it could fit in, because I'm guessing you're going to talk about language as well.
I don't think I said maybe.
Oh, you said definitely. You said it will definitely fit in well, yes. So, so this is a talk based on my teaching and the research that I've been looking at for teaching. And if you have any questions, then just let me know. If you have any critique, just let me know. It's quite hard to stop me from speaking, so it's a challenge. But if you do so, it's quite okay. So I always think about what I waste people's time on. I have 15 minutes with you now, and your takeaway from this presentation will be threefold. First is, you want to become an expert. How do you become an expert? You want to become better at learning yourself, or perhaps understanding how other people learn. And you want a fun anecdote to entertain a dinner party with. So these are the three things I promise that you can take away from this talk. So when lying on your deathbed, wishing you had 50 more minutes with your loved ones, thinking Aino stole those, you can think, but at least I got this out of this. So let's start with this. You want to become an expert. How do you do that? So we had the brothers Dreyfus in 1980. They made this model of skill acquisition. And the Dreyfus brothers was two brothers. One was a philosopher and the other one was an engineer. And they had been teaching, and they had been becoming experts themselves and watching others become experts. And they saw that there were some patterns. Some things were the same, regardless of what the subject was that it took to become an expert. So how many of you already know this Dreyfus skill of acquisition? You're very shy Swedish people. I'll go through it anyway. So you start as a novice, and when you're a novice, perhaps you've read a book about some subject. So you know the context-free rules. You know, if A, then B, if B, then C, and thus A means C. So you know these rules, and you can use these rules. And then maybe you watch presentations like you do today. And by watching presentations, you look at what other people do with this content. So you learn perhaps some guidelines. So people say, okay, these are the rules, but here are my best practices. Here are my guidelines that you can use in situations that are a little bit different. So you become what they call a beginner. And then what you do, you start applying it on your own. You start using the guidelines, you start using the context-free rules together, and you become competent. Which means that now you can respond to the unexpected. Now you have a little bit of experience yourself, so that if something unexpected happens, you don't just stop and panic, you actually know how to do these things, how to solve these things. Then you start discussing your experiences, perhaps also at conferences like this, perhaps in industry, wherever you are. You're discussing, so I did this, and this worked like this, I did this, it doesn't work like that. And then you become proficient, which means that now you can unconsciously combine the processes, and you know how to solve situations. You just do it. And then you get lots of practice. For instance, chicken sexing. How many of you have heard about this before with chicken sexing? Right, so yeah, thank you. So do you want to explain?
Determine sex of chickens in order to kill some of them.
Yes.
And keep some of them. The hens, keep the hens and kill the cocks, is it?
Yeah, so how do they learn how to do that? How do they become experts in chicken sexing?
That I don't know.
Yes?
By just doing it and being told when they did it wrong.
Exactly. Nobody really knows what you do. when you sex chicken. But if you're an expert, you can do it. And exactly as you said, you just do it a lot, lots of practice. And then you know how to do it. Then you become an expert. Which means you have an intuitive grasp of the whole situation, which is great. And then a lot of people think, now I'm an expert, I can teach this. Wrong. Because what you need to do is that you actually need to be able to go down to different levels in order to teach. And a lot of university professors, they're experts, and then they think they're the perfect people to teach. But it's problematic when somebody comes who's a beginner, perhaps even a novice, because they're not able to explain what it is they're actually doing. They're just chicken sexing these programs in these domain-specific languages, and it just works by magic. So you need to actually teach a little bit in order to understand. So it's sort of a chicken and egg. So you have to teach without being able to at first, but then you'll learn how to explain things. So other things I want to talk about. You want to become better at learning yourself, but I'm guessing that since your attention span is pretty short after the lunch, I'm going to skip to the fun part first. So I'll give you the anecdote to entertain a dinner party with. Well, it has to be a very geeky dinner party, unfortunately, but those are the ones I go to. So it's still something to do with being an expert. So how many of you play chess? How many of you would say you're experts in playing chess? We are in Sweden, right? A lot of research has been conducted when it comes to whether people are an expert or a novice. And a lot of the research have taken chess as an example. Because in chess, you know, there's a huge difference to being a novice and an expert. So that's why it's interesting to look at chess as an example. And one of the examples that I thought really interesting was this example, a research study made by Chase and Simon in 1973. I like old things that stood the test of time. As you'll see, most of the research that I'm talking about is very old. Some of it's even older than me. So what they did was they said, well, let's take a chessboard and put it up as if it was in mid-play. So this chessboard, if some of you can recognize it, it's the first time Big Blue won, Deep Blue won over Kasparov. It's the 22nd out of 32nd step. So it's really a mid-chess game, and it's a well-known one. And what they did was that they said, well, we have a lot of experts and we have a lot of novices, and we allow experts and novices to look at the board for 5 seconds, and then they have to put the elements on an empty board themselves, and then they counted how many elements was in the right place. And then they had a chance to look at it again for 5 seconds, and then they had a chance to change what they had on their own board. 5 seconds again, change, 5 seconds again, change. And then they counted how many elements did they get right the first time, the second time, the third time, and so on and so forth. And now my question to you is, who do you think performed the best? Do you think was the expert was better than the novice? Do you think they performed equally well in remembering this? Or do you think the novice was better than the expert? So think about this for a few seconds. How many of you think that the expert is better than the novice? 1, 2, 3, 4, 5, 6, 7, 8. Right. How many of you think they performed equally well? 3, 4, 5, 6, 7, 8, 9, 10. That's about 12. How many of you think the novice is better than the expert? 1, 2, 3, 4, 5, 6. It's about the same as. So these two are winning. Let's see what actually the research said. The master chess player is significantly better than the novice chess player in remembering where the elements are on the board. And we shall not go into a discussion about why just yet, because we need another example from the research. But just remember that the first time, after the first time the expert in general, like on average, watched the elements on the chessboard, he or she could put 16 elements correct the first time. The novice could put 4 elements correct the first time. Second time, expert is up to 20. Novice is sneaking up to about 8. Right? Keep that in mind. Because they did another part of the research as well. This is a random chessboard. This is actually created by JavaScript math just .random, so it might not even be a valid mid-chess play. And then we did the same. We said, well, now you do exactly the same. It's not a mid-play chess game, it's just randomly elements on the board. And I'm asking you again now, Do you think the expert is still better than the novice? How many will say yes? Do you think they perform equally well now? 20. Do you think the novice is better than the expert? 8, 7, 8, 7, 8, something like that. Let's see what happened. See, so not surprisingly, the novice who only works with the context-free rules, where it's actually just a remembering game, does exactly as well. 4 the first time, 7 or 8 the second time, 14 the next time. So the novice graph is exactly the same as it was before. But what is happening to the expert? The expert started with how many? 16 the first time. And now 2. And second time the expert had 20, and now 4. What's happening to the expert? Any ideas? Yes?
It's just random. So the expert has problem recognizing the pattern.
So
he cannot re-replicate the whole situation.
no. So because it's random, he can't use the patterns that he has in his head, so he can't replicate the situation. Yeah?
But why is he not as good as random?
Why is he so much worse?
Yeah.
Well, it's not a game of chess anymore.
Yes, it's not the game of chess anymore.
Well, he's spending time looking for the patterns that are not there, right?
Exactly. So he's spending a lot of conscious energy looking for the patterns that are not there, and that is confusing him from even remembering the simple task of where the elements are. Or her, being in Sweden. So novice and expert in chess, and actually for everything. But if we zoom into chess, the interesting thing is that all of the research that has been done about novices and experts in chess, they have been looking at how many elements do they look at. They've been sort of tracking their eyes. Are they looking at one? Are they looking at patterns? How long are they looking at different patterns? They've asked them how many next moves they're thinking about. And what they got out of the research was that the expert knows a lot of board configurations and their associated moves. So they're experts by learning the different patterns, but also by trying again and again and again and drilling it into the brain, all the patterns and the automations. The novice knows few, if any, board configurations and their associated moves. And the interesting thing is that when they're thinking about the next move, they're thinking about an equal amount of next moves. But the expert is only thinking about the good moves. And it's the same as when I'm teaching my teenage children to cook right now. When we need to figure out what spice should we put in the soup, I think about perhaps 3 different spices, and they think about 3 different spices, but they think about the wrong spices because they don't have the experience. I think about the right spices. So that's the way it makes sense to me. So this was the thing about an expert and the entertaining anecdote. So why should you listen? You want to become better at learning yourself, or perhaps teaching others so that they can learn better. But before I start that, I need an activity, one more activity. And if you don't like activities, you can just pretend that you're playing along. So let's divide the room, which is already done. So that's first time. Really, really easy. And then when you sit over here, right? I'm going to show you some words. I'm going to show all of you some words. But if you're sitting here, when I'm showing you a word, you should count the letters and say the number in your head, right? So for instance, if I say number, you're thinking 6. And then the people over here, when I say a word, say a related word in your head. So for instance, if I say number, you can say 17 or counting or something like that. Make sense? And do not write it down. But later I will ask you to do so. Are you ready? Hammer, drive, bottle, steep, coat, hand, rhyme, banana, bell, game. That's it. Now I'll let some time pass. So perhaps you forget it again. Because now it's story time. So this presentation is built around a story. So imagine that you're working somewhere and you get an apprentice And it is your responsibility to teach this apprentice how you work in this company. It could be a software system, it could be the process, the way that you communicate, but you're the one in charge, you're the one responsible for teaching this person. So what do? Well, you talk all day, you use numerous examples, you show and you tell and you say when you do like this happens, but it's not working. The next day, he or she has forgotten everything. A week after, all is gone. You say the same things again and again. Can you recognize this? Yeah, right. Let's look at how the brain works. So in 56, Miller talked about saw a cognitive architecture. And he said that, well, what we do in the brain is that we're chunking information. So we're not taking a whole lot of information in as a stream, but we're trying to chunk the information and then put it in our brain. And here's a picture that I've made for you. And what you can see here, apart from the fact that it's good that I'm not a designer, is the nose, the long-term memory, and the working memory. So it's like a head seen from above, where the nose actually is up here, but I can't really show that. Maybe I should change that. But so we have the long-term memory. This is where we store all the things that we've learned. And then we have the working memory. This is the thing that can process. The things that come in, what we sense, what we try to understand, we make sense of in the working memory. And when he made this architecture, he said that people have 7 elements in their head that they can use. 7 plus minus 2. You probably heard that. You can only focus on 7 plus minus 2. Unfortunately, new research shows that it's down to 4. And I don't know, I'm sorry on behalf of the young people, that's how it is. You just can't have as much in your brain as old people, or maybe the research was wrong in the beginning. So what you do, whenever you hear something, whenever you want to try and understand something, you use the working memory. So these are sort of active, these 4 plus minus 2 elements are active. You're trying to make sense of things. And then what you're doing when you're trying to make sense of things is that you're trying to put it into a chunk or a pattern. You say that this goes together. This is something I will understand together. And then what you do when you're learning is that you're encoding these patterns in your long-term memory. So once the short-term memory understands this, it will try to place it in your long-term memory as a pattern or as a chunk. And that means that now you have this in your long-term memory, you have learned this, it is something that you can make use of, and then whenever you need to make use of it, you can pull it out. And the interesting thing that happens here now, when you pull it out, when you're actually decoding the patterns in your working memory, is that it no longer takes up 4 elements in your working memory, it only takes up 1. Because you use 1 reference in the working memory to work with this. And that is why you're able to understand complicated things. It's because you chunk it and you learn it little by little, and then you could imagine that this is possibly, this reference is then tied up to another pattern here with another reference. So you can have actually as complex and as abstract things as you could imagine or even cannot imagine in your long-term memory, and you can pull it out just with 1 reference. And I spend a lot of my research time working on design patterns, and design patterns does exactly that. It tries to take some information and it chunks it for you into a pattern with a name, so you can use this name as a reference. And then you can actually, like Martin said, you're increasing the mental power if you're making sort of macro systems like pattern names or references. I'm just making use of what you said, maybe it's not correct, but it's just doing it like that. So you can use a lot of processing power here by putting this into a macro or a pattern. So when you're learning, it's a good idea to think of things as patterns. So perhaps there's already patterns in what you want to learn, or perhaps you can create your patterns yourself, or perhaps you can ask the people who are teaching you, what are the patterns here? Let me give you some examples. The visitor pattern, for instance. How many of you know the visitor pattern now? It is a language conference, so I'm expecting at least 14, exactly as I expected, to know the visitor pattern. And the visitor pattern is one of the most difficult to understand design patterns in the Gang of 4 book. And that is why you need to understand it little by little. You have to understand this tree first, and then you have to understand this tree, and then you have to understand the communication between these trees and how you can make use of it when you're using the visitor pattern in your code. And you wouldn't be able to just understand the visitor pattern in one go. you would need to learn it in the chunking way. But it's not necessarily just design patterns. It's also, if you're using Excel, then you can say that, well, you have a DSL with the functions in an Excel spreadsheet, and there are patterns in those functions as well. But also, if you're teaching, if you're selling, if you're in marketing or sales, there are also patterns. Never lose the attention of the customers and create a sense of urgency. These are also patterns. It's a reference. Create a sense of urgency. You might not understand what it means, but if you have been trained in this, you have a pattern in your long-term memory that says, well, if that is what people say, then it means this and this and this and this and this. So you store it under that reference. And then you can apply the patterns. And the interesting thing is that some people say, well, we don't use patterns. For instance, I talked to somebody who worked at Google in Aarhus, and asked them, so what are the patterns that you're using? And they, at that office, they're above everything. They don't need agile processing, they're too smart. And they don't need patterns because they're too smart. But I found out they had at least one pattern. They got something called a double bottleneck. Aha, I said. So when you say the double bottleneck to new people, what do you actually mean? Well, we mean that we're optimizing all the time. The V8 for the Chrome. They're optimizing all the time. And then sometimes we know that there's a bottleneck in the code. Somewhere it's slow. And we don't know where in the flow it's slow. So what you would normally do is that you would guess where the bottleneck is, try to solve it, and then see if it solves the problem. But they've noticed that that's not really efficient. So they use the double bottleneck instead. So what they say is that if we think the bottleneck is here, like for instance fetching things from the database, or interpreting this, or dealing with this expression, then they do it twice. So they simply encode it to be done twice. Fetching it twice, interpreting it twice, encoding it twice, and then if the bottleneck is bigger, then they see that they've found the right place. And it's normally always easier to do the work a second time than to try to solve it. So they have a pattern as well. And you probably have patterns as well, even though you don't think you do, but I'm sure you have patterns. So what if the apprentice still doesn't get it, even with the use of patterns? It's still, oh, I don't know, what did you say yesterday? What button should I press? It's really difficult. So I'll take you back to the beginning of this century. Right after my PhD, I was sent out to teach in industry. So I was sent out as a young blonde girl teaching 45-year-old men who had been programming for 20 years to learn a new programming paradigm. It wasn't fun at all, but that's a different story. Now I don't think 45 people are old anymore, but that's also a different story. So I was sent out to teach this course, Introduction to Object-Orientation, Object-Oriented Analysis and Design, and then Java programming, of course UML, and rational unified process. Of course, it was before Agile. I was young and I needed the money. So, and it was a huge company in Denmark. So I was set out I was teaching 8 times for all the developers in the development department. And I had my intro to object orientation at the University of Aarhus back then was everything is object oriented. It is the only way to work. So I had learned some procedural and functional, but I hadn't used it. So to me, all my patterns and my pattern automations in my head were about object orientation. So whenever I saw a problem domain, whoosh, out came beautiful object-oriented code. Not exactly what happened when I was teaching these people. I thought that if I gave them a problem domain, then they would turn it into beautiful object-oriented analysis and design, and then beautiful Java code. So I gave them an assignment, and this is what I had in mind, this is what I expected, because they're all very smart people, that's what they told me. And this is what they came up with. Something a little bit blurred, couldn't really, some of the methods went out of the boxes, and there were some methods in between the boxes, not really pretty object-oriented programming this. And I was wondering, what is it that's happening? Are they actually stupid? That's, of course, that's my first interpretation, they must be stupid. And so I tried to explain it in different ways, and I didn't understand. But luckily, as I said, I had this course 8 times. So after the 3rd time, when I saw the same pattern, and I just thought, they must be stupid, I suddenly noticed something about this. Ah, I thought, it's because they have a procedural brain. So whenever they see a problem, they solve it without even thinking about it because they're experts in this. It's like the chess player. The chess player is an expert in board configurations, and the next move after the board configuration couldn't possibly even explain why he or she chose the next move, but they would know what to do. And it's the same with these people. They had been coding like this for 20, 25 years, and they were experts. And whenever they saw a problem, out came the solution. And of course, then, when they had to implement it in the Java language, it wasn't really pretty. So that's what happened. So I tried in the beginning to just say, well, whenever I started the course, just forget everything you ever learned. And then I'll teach you something new. That doesn't work. So I figured out what to do. At the time, I didn't know why it worked. I know now, of course, because of the chunking and the patterns. But what I found out was that instead of saying, well, you go from this problem domain directly to the code, let's try a smaller step. Let's see if there's some intermediate language that you can understand, that you can go to. Right, and if this doesn't work, if you couldn't make like UML diagrams, if that is too difficult, let's see if we can find another intermediate step, which is a shorter step for you that you can actually do. So I tried to cut my thought process into different steps. And then I tried to figure out how short the steps had to be for them to be able to do it. And that's what I'm doing now if I'm teaching as well. If somebody doesn't understand something, I try to think about, okay, so how do I actually come from here to there? What are the thought processes that I do? And it's not easy. And then try to make steps. And if that doesn't work, I make smaller steps. But you can always find a step that is so small that people actually are able to understand it. So it brings me back to Søren Kierkegaard. And as you know, I'll just read this aloud because it's in Danish. At man, når det i sandhed skal lykkes en at føre et menneske hen til et bestemt sted, først og fremmest må passe på at finde ham der, hvor han er, og begynde der. So that you, when you want to succeed in bringing a person to a certain place, must start by finding out where he is from the start and begin there. So the important thing is, whenever you want to take somebody somewhere with their brains or with their feet, you have to figure out where they are first. So ask them, what do they know already? And that's also back to what Martin said. Find out what the concepts are. What are the words they're using? Use those words to figure out and to start from there. But what if the apprentice still doesn't get it? Even with the use of patterns, even if you know where they start, what they already know, what they're experts in, it's still problematic for them. Well, perhaps you can think about learning preferences. There's something called learning styles that people used a lot in Denmark some 10 years ago, but newer research says that it's not learning styles, it's learning preferences, because it's just a preference and it can change. You know, you shouldn't put people into boxes, even though it's a lot easier. So I still put people into boxes, but I use a different word so it's not so obvious. And one of the models for learning preferences is this Felder-Silverman model, and one of the aspects of it is the global versus the sequential learner. This is interesting to me, and I'll tell you why when I've just given you the concepts. Because if you're a global learner, then you like to see the big picture. You like to understand the big picture before you get any details. Because if you are a global learner and you get details, they just disappear again. You're not really interested, you don't know where to put them. On the other hand, if you're a sequential learner, then you need to understand these details before you can move on. If you don't understand this detail, you don't want to hear about the big picture, okay? It's just confusing. You want to hear another little detail. And that was interesting to me because I'm very much a global learner, which means that I take things in big chunks and I understand it. That's why I like software architecture, UML diagrams and patterns. I like these broad lines. And the details, I'm not really that bothered with the details. And the problem with being... Don't help each other. Okay, have you had time enough? Right, now I'll show you all the words and count how many you remembered, okay? Count how many and put that number on your piece of paper. Okay? Now, put your hand in there if you remembered at least one word. Yeah, we can all be together on this one. What about if you remember 2 words? Right? Look at the difference. 2 words. Look at the difference. Okay, 3 words. Keep your hands up. Look at the difference. 4 words. 5 words. Okay, really impressive over there. Have you been cheating?
That's what you were going to do.
Ah. Anyway, so what was the difference? So your left, you had the number of letters in the word, and you had the related word. What was the difference between you two? Anybody?
You could backtrack.
You could backtrack. Why could you backtrack?
I realized I remembered my own word, and then that's harder in their case.
It is, exactly. That was exactly the point I wanted to make. You remembered your own word because it's your word. You were able to relate my word to something in your own brain. And that made it easier for you to remember. So that's something called constructivism that Piaget talked about. That learning is constructed in the brain. And that means that you need to construct what you're learning on top of something that you already have, like words or concepts that you already know. And if you're not working with that, then it's problematic. Let me show you. So this is again my beautiful picture of a brain. Now, so this is a brain of a student, and here is the content that is already in the brain of the student, if you can imagine that. And I try to teach the student something, so I'm activating the working memory, and it's then being stored into the long-term memory. And the day after it's gone. I've definitely seen this. So you said yes several times, and you pushed all the right buttons yesterday. What happened? It's gone. You said you understood. Yes, I did understand, but it's gone now. So what's happening is that when you're in the when you're sleeping, your brain is helping you preserve energy. You know that the brain is spending a lot of energy. It's really consuming a lot of energy. And what we are really trying to save energy. That's why we get fat. We want to save energy for an emergency situation. And the brain is really energy insufficient thing. So you want to keep the brain as efficient as possible. So when you're learning something, what you're doing is that you're drilling these patterns into your mind in the light sleep. So for instance, if you're learning how to ski or you're learning to play an instrument, you might have noticed that when you're sleeping, you are performing what you did during the day. Or when you're removing weeds, your brain is going through the pictures of weeds related to other plants. So in the light sleep, the brain is really trying to make you remember, make you learn. Drill the patterns in so that the synapses can react fast. Unfortunately, in the deep sleep, what the brain is doing is taking garbage collection in your brain. And it does so to preserve energy. Because if you're learning something which is not related to something that you already know, i.e. something you already need, then who cares? Let's just remove it. We don't need, actually, to have electrical impulses to that part of the brain, because apparently it's not necessary for us to remember this. So we just garbage collection in the deep sleep, and then the next day it's gone. So what you need to do is that you need to figure out what's already in the head, and then you need to work with that. And that's something I've tried to work with at computer science, both at university but also at other places, other schools, because what I saw when taking math courses in primary and secondary school and computer science at university is that it's mostly male speakers, mostly male lecturers. And the examples that they had were about cars and beer and football. So the boys could remember all the examples because they could relate to things. I'm really overgeneralizing here, I'm sorry. I know that some women like beer and football. I personally love beer. But it's interesting to think about what it is that's in the mind of the person that you're talking to, so that you can relate those examples to what they already have in the head. Otherwise, so now that you know all of this, how would you explain the Danish number system? I tried. So this is the first time I'm trying this. I'm going to try to teach you all the Danish number system based on the theories we just went through, okay? And for those of you who are not aware, you can see that in Sweden it's 97, and in Germany it's 97, and in Japanese it's Gojonana. Anybody speaking Japanese here? Gojonana, something like that. well, anyway, it's and in French it's 97, and in Danish it's 97. Easy, right? And then somebody will say that if you can't explain it simply enough, you don't understand it well enough. So that's really a challenge. This is how you would explain it if you just saw it in a book, right? So let me just take you through this. 50, you pronounce it 50, but you should actually pronounce it 50, because that's what it stems from. And what it means is the half of the third times of 20, but we don't pronounce this anymore, because this is no longer a Danish word that we use, this sin, right? And it's the same, that's just the same all the way around. So 60 is 3 which is 3 times of 20, but we don't say times of 20, we just know it. And the 70, 70, 50, easy, right? Not really, because the problem is that we're trying to make it harder for ourselves. Our number system started when we were based on a 20-based number system, which means that we have words like snes, which means a dozen, which means 20, and we still use that in the language. We also have something called dusin, dozen, 12. But I have to say that even when I say to you, we still use the word snes and dusin. I said it to my teenage children and they just had a blank stare. So perhaps people are not using it anymore. But anyway, and then we have the old expression for times. When you say 3 times 20, the times is sinne. It's the way we said times something in Danish, but nobody knows that word anymore. Nobody uses that word anymore. And then we have the unintuitive way of labeling the next 20. So it's the third time of 20 or the fourth time of 20. But let me use constructivism here because it's not that far away. So 5:30 in Danish is not 5:30 as it is in England. It is 5:30. It is the half of the 5th hour. Right? And that's the same as when you say the 18th century. You're not talking about 80 something, you're talking about 17 something, right? So we know this. We know this unintuitive way of counting the number of 20s. We also use it in centuries. We also use it in pregnancies, because if we say we're in the 3rd month or the 3rd trimester, we mean the month or the trimester leading up to number 3. Still some blank stares. So I tried to make it visual here, like a global setting. So our number system was based on 20s, okay? So what we do is that we show 50 as times 20. And times 20 for 50 is 2 times 20 plus the half of the 3rd times 20. And then 60 is just 3 times 20. 70 is 3 times 20 plus the half of the 4th times 20. 80 is 4 times 20, and 90 is 4 times 20 plus the half of the 5th times 20. Okay, we're getting there, right? How many of you would be able to explain this now? How many of you would be able to explain it before? Okay, I think I have to work on this.
Could you say halfway to the 3rd times 20?
Yes, but we don't.
that, to me, when I was looking at your description, I thought that sounds like halfway from the 2nd time 20 times 20 to the 3rd times 20. It's halfway between those 2 steps. So
yes.
For me, that would be a way of understanding it.
Yes. So perhaps.
Halfway
so I could have a third line here where I say this is actually how you should understand. That's a good idea. But it's hard as a Dane to get away from this, because we just say 70 or 50 or 90. And we don't think about that it's actually 50, 20, we don't think about it. And most Danish people don't know this. They don't know why they're saying this. You should ask them, especially after a few drinks. That'd be fun. But I have a few more minutes. Yes. Right. So what if the apprentice still doesn't want to listen to you? Even though you're using patterns, you're using constructivism, you're figuring out where they are, you're using the right words, the right language, the right concepts, still not working. They're not listening. What do you do? Right. How many of you remember what this means? Anybody who can read it, just put up the paw. Yes, down there.
Logos, pathos, ethos.
Yes, logos, pathos, ethos. Exactly, 1 point. And why am I talking about this? Well, I'm talking about this because it stems from Aristotle. It's his 3 modes of persuasion. How do you make people persuaded about what you say? This is something I'm thinking about when I'm giving talks like right now, and I'm going to tell you how I'm doing it. So logos is what you're saying. It is, of course, important that you know what you're talking about, right? And that is why I'm talking about something that I have worked with for 20 years, and then I have done research in. So I know what I'm talking about. I'm very excited about this subject. I have pathos. I am actually really excited. I don't have to fake the excitement like I do when I'm teaching databases, where really... sorry. I appreciate that some people like it.
I used to.
Yeah, you were young and you needed the money. Yeah, yeah.
You have to be some.
Yes, yes, yes. But some people have to, right? And ethos, who they think you are. And I am fairly unknown. And that is why when I introduced myself, I had to say that I had been teaching for a lot of years. And I had to say that I had been doing research, because that might persuade you to actually listen to me. If I was just a nobody, maybe you wouldn't. So having all these 3 things is really important when you're giving a talk, or when you're teaching, or when you're trying to teach somebody anything. Luckily, as in the love songs, 2 out of 3 ain't bad. So if people don't know who you are, as long as you know what you're talking about and you're really passionate about it, it's actually okay. You can get away with it, right? You probably, the youngsters of you would know that that is how you have to be. Just when people don't respect you from the first hand, you have to really know what you're talking about and you have to be passionate. Otherwise, it's not good. Interestingly enough, you can be pretty boring if you know what you're talking about and people are expecting that they want to listen to you. I do a lot of conferences, so I know this happens, and people love these talks, even though they're talking to their stews, and still people love them. But this is also something I've seen. Sometimes, if people really want to hear what you're saying, because you're famous, and you're passionate about what you're talking about, you can get away with saying anything. And you've probably seen that as well. And it's just a pattern I can give you for free. So think about it whenever you're teaching, or whenever you're giving a presentation. How many of these do I already have? Should I work a little bit with one of them? Because you can fake almost all of them, or work towards it. So think about that. And that's... I talked about how you become an expert, how to improve your own learning, and I gave you an anecdote to entertain a dinner party with. That's it. Thank you for your time.